cloud architect for Red Hat. Some of you may have been downstairs, I already said this, but I'll say it again. I work in a group called Engineering Operations, which is part of a larger group called Hosted and Shared Services. We're actually like a company within inside Red Hat. We have our own developers, we have our own system administrators, we have our own user interface people. We basically have everything we need to function as a group. What we do is we service the 2,000 plus engineers we have within Red Hat. So we develop software and manage systems that are related to Red Hat shipping products. So things like code hosting, code compilation, bug tracking, quality assurance, automated testing, all those kind of things. So just a few points I'll say about tonight's talk before I get started. Because I am an employee of Red Hat, I apologize in advance if this starts to stray into any parts of the sales pitch. So if it starts to get like that, feel free to throw something at me. I've tried and cover all the technologies that are out there and give some examples of not just Red Hat products, but other products. If I miss anything, please yell out and let me know. As I said, when you're surrounded by one company's products day in, day out, sometimes you get a bit of tunnel vision. So once again, let me know if there's anything I've missed. Tonight I'm going to cover quite a few different topics, but not particularly in depth. If you have questions, feel free to ask questions. Well, there'll be time for questions in the end, and I can kind of go into anything in a bit more detail. But I've kind of picked a few different bits and pieces from around the private cloud space and DevOps to kind of cover tonight. So I'm focusing on private cloud here, not as a replacement for public cloud. So I'm not trying to get into an argument with private versus public or anything like that. But I'm trying to sort of show, I guess, or position it as something that complements it and the niche space that it occupies. For those of you who are already using and deploying on either private or public cloud, you probably know some parts of what I've already talking about tonight, so I do apologize if those aren't particularly interesting to you, but hopefully at least you can take away what's happening in the private space for your own interests. And sorry, when I say private cloud and public cloud obviously I mean providers like Amazon, externally hosted provider you pay for, and private cloud is essentially software that you run on premise to do your own stuff. So an overview of what I'm going to cover. I'm going to quickly go through the layers in the software deployment environment. A lot of this stuff is probably everyone knows, but I'll go through it very quickly. Software as a service, platform as a service, infrastructure as a service, and then kind of the differences between infrastructure as a service and platform as a service. I'll quickly go through public cloud versus private cloud and what some of the advantages of private cloud are. I'll talk about private cloud and how it can be used as a kind of a small vessel for bridging the DevOps gap, so going from traditional silo development within a company to a kind of a more DevOps approach. And then I'll kind of show an example or talk a little bit about building your own private cloud using OpenStack as an example. Once again, I mean, I use OpenStack a lot. Red Hat obviously has an OpenStack product, but the same principles and often the same tools can apply to any of the private cloud software out there. OpenStack is usually a common choice for these types of things as well, because it is the most mature out there for the private cloud space at the moment, although there's a lot that is up and coming. And then I'll kind of briefly talk about what I think the future holds, which may not necessarily be true. So layers in a software deployment environment. So this should be fairly self-explanatory and fairly common to everyone. So at the bottom, you've got hardware. Now, more often than not, you actually have hypervisor on top of that before operating system. So you've got operating system, Linux, Windows, etc. And then you have the application platform, which can cover things like application servers, so JBoss, WebSphere, WebLogic for a Java application server, virtual machine interpreters, so JVM or Python interpreter or something like that, system libraries or application libraries, and data stores such as databases and things like Redis and all those kind of fun things. And then obviously, typically you have the application on top of that. So you can see here I've kind of put some bars on the side to kind of indicate which layers each one kind of covers. So the blue kind of indicates typically what you get out of the vendor or the solution that you implement that covers that. So platform as a service obviously tries to cover a lot more, whereas infrastructure as a service kind of doesn't cover as much. I put it halfway through operating system because you do get control over the operating system, but it's kind of halfway there because often they give you pre-built images to start from. So These layers that I've got here as well obviously aren't true, and even from different platform as a service, infrastructure as a service solutions, what they do and where they lie differs. There's no real concrete term or definition, especially because it's always changing. So software as a service, very simple, functional application provided to you on demand, no operational development overhead from yourself, limited or no ability to modify the application. Typically, that is kind of changing. So public software as a service solutions, things like Gmail, Salesforce, and even Pingdom, which you might use for operational work. Private software as a service solutions, things like Confluence, Jira, Zimbra, so forth. So the next layer down, platform as a service. So platform as a service is a development and deployment platform that is provided to you on demand. So it's the actual platform underneath the application and everything down. So you develop the application yourself, and then the provider handles the deployment and the operation side, mostly. So some public examples are things like Google App Engine, OpenShift, and Heroku. Some private examples are Staccato and OpenShift Enterprise. So infrastructure as a service goes down even lower than that. So that's entire systems. Typically they're virtualized, or there are some bare metal as a service offerings that are provided to you on demand. So freedom to run whatever operating system you want, whatever software you want, whatever platform you want, you can change it, you can configure it, everything you want, all the way down to the operating system itself. The provider is responsible for keeping just the system itself up and running and network accessible. So that's typically what we call ping and power support. So obviously, this should come as no surprise, the public providers of these kinds of services, Amazon, Rackspace, Ninefold in Australia. Private solutions that in the same space, so OpenStack, big one. OpenNebula is another one. CloudStack is a new up-and-comer, and then vCloud, which is VMware's private cloud software suite. So infrastructure as a service versus platform as a service. I guess I'll start by briefly mentioning, I would definitely not say that there's one that's better than the other. They're both solutions for different types of problems, and with everything, and with everything I'm going to talk about tonight, it really depends on your situation. But I'll kind of give a few points, kind of general points about the differences, or the pros and cons of the two. The trade-off, ultimately, it's all about the trade-off. The trade-off is power and control versus responsibility between you and the provider or the administrator. So the provider if you're using a public offering, and the administrator of your infrastructure or platform as a service if it's a private offering. So that's really, in a nutshell, rolling up all the issues. That's what it is. If you want to be responsible, or if you want the power and control to do something, to change the platform or whatever, they give you the responsibility as well. Platform as a service has reducing deployment operations overheads, obviously. So that's one of the really stellar, and very big wins, why it's made so much headway so quickly, is because, you literally, for a developer, you can just have a Git repo, you put code up, and you can press some magic buttons, and it'll just deploy. And a lot of the solutions will do automatic scale out and everything. They'll handle the security patches, they'll handle all of that for you, and they'll just give you a bill at the end. One of the downsides to platform as a service is it is a fixed platform that sometimes cannot provide enough flexibility or features required. And this is especially true if you are porting existing applications. So we've had classic examples of this in my line of work. We have long-running applications that might run on J2EE applications, Perl applications, or Ruby applications, and we choose a platform, Heroku or OpenShift or whatever, to try and just take the code and really, literally just dump it into. And then you hit some of the kind of constraints with the platform as a service. It might be running slightly different versions than you used to. Often or not, they're very strict on security, which is a good thing. So you can't do, maybe you need to open a port or talk to something randomly or do something on disk, which they're very inflexible about doing. And that's not necessarily a problem with platform as a service or that particular vendor. It's just, that's the nature. They can only provide that automation and that compatibility by locking down what you can do and being able to enforce that. So that's the trade-off. Infrastructure as a service obviously gives you the maximum amount of power. So you can, once again, you can do whatever you want, but then often, typically, you're faced with all the responsibility. So generally, when I say what I kind of overall what I kind of think is, at the moment, platform as a service, it's really good. It is starting to take off, and as I said, people are using it. It is difficult to get existing applications in, like, obviously the marketing spiel from anyone for these kind of things is, yeah, just take your code, throw it at it, and away you go, nothing involved, but it's never that simple. I think now that these kind of platforms as a service solutions like Heroku and OpenShift and that are out there, and you'll see more and more startups and more people starting from the ground up with those in mind, already targeting those from the ground up, they'll be a lot more successful because they'll know all those limitations from the ground up, they'll be able to design their applications for it. The success of those will come probably from a new breed of company and application that's being deployed. Maybe. It'll be harder for people to take existing applications, but that may not necessarily be the case. So for people who have existing applications or more legacy stuff, usually they try and target infrastructure as a service because it's very easy for them to get all the power they need to be able to, we need a special custom Apache module or something for our thing to work, and then they can do that on top of all of the stuff. They can already do everything they already do and just put it on infrastructure as a service. Not sure what happened there. So private cloud versus public cloud. I'll start at the bottom then. Public cloud allows you to outsource large portions of operational overheads and costs. So that's obviously the huge advantage that the public cloud came in. And that was what a lot of people focused on quite a lot. It was just all about outsourcing. It was kind of the new wave of outsourcing. You just pay a public vendor for only as much as you use, and that was the benefit. And that is a real benefit till this day. That is a fantastic benefit. Once again, if you're a small startup, places like Amazon and public cloud are fantastic because you don't know what your infrastructure costs are going to be. You can just use as much as you want. You can start off small. You can get access to extra resources as you need it. You don't need to sink hundreds of thousands of dollars on infrastructure just on the off chance you might become successful overnight. So that was the real power, and that's still a real trump card for public cloud. So private cloud, it's able to leverage existing capital expenditure to save costs. So what I'm talking about there is obviously if you're a traditional company and you've already got a lot of stuff, so you're not using public cloud, you're just using traditional kind of maybe virtualization environment or something, and you're looking at moving to either private or public cloud. The cost argument always comes up, and I could sit here and talk for hours about the whole cost argument relating to just public versus private cloud, and there's still hotly debated over the internet by people from both sides, typically with an agenda or a product to sell. But at the end of the day, it is quicker and easier if you've already got data centers up and running, you've already got hardware going, and you've already got all that kind of stuff. It's easier for you to just then adopt a private cloud because you've already got those costs kind of covered versus having to go on Amazon and pay for everything from the ground up again. So another advantage of private cloud is you can maintain data security and privacy. So obviously that's still. So the Gartner Group often go out and have these big powwows with CEOs, CIOs from everyone out in the industry, and they still maintain that the number one blocker for companies, they're just like, why haven't you gone out and used Amazon yet? It's still one of the biggest blockers is security. Whether that's right or wrong, whether that's just a maturity thing, whether that's just a problem that will be solved technically, we're still yet to see. But security is still an important issue, and especially if you've got any kind of regulations or anything to meet. So with private cloud, typically, there's no vendor lock-in. I say no vendor lock-in with an asterisk. It's not as much vendor lock-in. So for those of you who have been in the industry long enough, trying to get a good example. So back in the day, obviously, this example comes to mind because I'm from the Linux and Unix background. Back in the day, there was a lot of the hardware vendors had an absolute field day with vendor lock-in because back then, if you bought HP, they sold you HP UX. If you bought IBM, you got AIX. And if you bought Sun, you got Solaris. So that was, you got the operating system on top, which often tied in your development quite tightly because things like languages that ran everywhere and all that kind of stuff weren't quite as prevalent yet. So that was fantastic for them because they would get the sale, they'd get you into Sun, and then they basically knew that a customer forever because the idea of moving was so difficult. Linux was one of the things, not the only technology, that came along and smashed that. We ran on a common architecture or a few architectures, And the idea was that you could go and buy HP, you could also go and buy from Dell or anyone else and run the same operating system and then the same software and everything else on top of it. So that kind of broke that whole vendor lock-in apart, and that was a big win, and I think that's one of the reasons why Linux was so successful. So now when people are going back and thinking about public cloud again, it's starting to move infrastructure and stuff onto the public cloud, they do have to be aware. This is not necessarily, I'm not trying to disparage the public cloud providers or anything. I still think, obviously it makes sense, but at the end of the day, they want you to use their stuff and they want it to make it, it's financially good for them to make it difficult for you to move away. So there's a lot of projects out there that try, because the pie in the sky idea was that you would be kind of like a stockbroker for computing power, that you'd look at the prices of Amazon, you look at the prices for Rackspace and be like, oh, Rackspace is so cheap, they just dropped their prices, I'll just press a button and magically all my services and everything would redeploy across onto Rackspace. That was supposed to be the dream of public cloud, is it would drive down prices because you could just kind of shop around. And that is true, and to a degree you can do that. There's software and libraries out there to do that, things like Fog, Delta Cloud is another one, and so forth. But at the end of the day, it isn't quite as simple as that. And the more features you use from a particular provider, the more you're getting locked into that. So, once again, that's not necessarily, I'm not trying to disparage Amazon or any of the providers at any rate, Rackspace or anyone else, but it's just something you've got to always be aware of, that the more you push out there, the more they basically own of you. And so, and vendor lock-in is still a problem with private cloud, so that's why I say asterisk. It still is a problem with private cloud if you choose a private cloud vendor or supplier who is, for example, closed source, because you've got all your stuff right up and running on them, you've got to keep paying them licensing fees. So it's still something to be aware of, regardless of what you choose. It's always about vendor lock-in. And finally, private cloud, it allows you to innovate and grow at your own pace and not dictated by vendors. So similar to the point above, it's something that at the moment, right here and now, is probably nothing to worry about. But it's something that maybe 5 years in the future, I actually do see an important point. So at the moment, if you had a brilliant idea that you wanted to change the way your cloud infrastructure worked, like if you were deploy on Amazon, if you wanted to, provide coffee as a service or something like that, to some people or something, Amazon own the platform, it's all closed up to you. You can't actually change the way it works. And that's fine, because Amazon or Rackspace and all those providers, they lead the innovation market at the moment. They do amazing stuff. Like every day they just come out and smash everyone in terms of just everything they do and fantastic new stuff, because they are the leaders at the moment. But as private cloud and as more competitors, even in the public space, start to come up, innovation, you once again, like vendor lock-in, you want to make sure that you're not just forced to innovate at the rate that your cloud provider is using. So it might be, supporting a new database. Maybe there's a new database type that comes out and it's amazing, and then you've got to wait for your cloud provider to be able to support that. So now I'm just going to talk a little bit about private cloud and how it can be used as a vessel for bridging the DevOps gap. So this has been talked about a little bit briefly by a few different DevOps bloggers and people around the internet as a possible way of helping current companies kind of bridge the DevOps gap. Using infrastructure as a service is actually a catalyst for that. So what I kind of mean about that is this is targeted really at probably a large company that's very traditional in their software development model. So it may not apply to all companies, but this is the kind of scenario infrastructure as a service can be used to actually help a kind of DevOps revolution. So if you imagine a big company that's got a traditional software environment, so they have they've got a traditional ops team, they have a development team over here, they've got a networking team, they've got their storage team, they've got a data center somewhere with all this hardware in it. They develop all these products or run all these systems or whatever. Typically what happens between that, not always, maybe this is my experience, they often operate around that silos that I talk about, operations over here, developers over here, networking guys over here, and they only each know kind of what they need to do. And there's a lot of process and red tape. Like if you need a firewall port open, you've got to send a ticket to the networking guys, or you've got to call them up. sacrifice a goat or something. Something to actually kind of get things moving. So one of the lessons that that cloud actually taught us that I think is often overlooked is that its computers and APIs actually work better than people and process. So does anyone here, I'm not sure, does anyone here work for Amazon? No? Okay. So the story, I'll give a very brief story about at least what's been released publicly, I'm not sure the truth to it, about how Amazon AWS came about. So the idea was Amazon, it wasn't like they sat down somewhere and said, hey, we should make this thing called public cloud and sell it to people. It was all about Amazon the store. They wanted to make sure that they never lost a sale. So no matter how busy it was, not time of year, Christmas time, big periods, slow periods, they just wanted to be able to make sure the website stood up, never got overloaded, and they would keep every sale. I think that was the motto, never lose a sale. Fair enough. So then they kind of looked at, how do they scale up and everything, and they could buy hundreds more servers and they could buy all this stuff. And then they kind of noticed that, once again, if on a Thursday night, someone goes and talks about, on television, someone talks about a new product, everyone rushes to Amazon to go buy it. And then all of a sudden, to bring all those new servers up and running, they needed to call the networking team and do all this stuff, and all these little bits and pieces that were manual and people throwing tickets around and all that kind of stuff. It just wasn't going to be fast enough. So they internally developed the idea of, each team should just expose APIs and we can do all this stuff programmatically. So programmatically create a new, storage, iSCSI volume on the storage, and then programmatically create a new network and all that kind of stuff and automation. And that's kind of how it came about. And then they realized it was so fantastic that they would publicly offer that. So I think once again, obviously the cloud, public cloud revolution happened and it was fantastic. And once again, I think there were a lot of big ideas people took away. Oh, it's about outsourcing, saving money and everything. There was a little message there I personally feel was lost. Maybe not so, maybe other people know it. It was that computers and APIs work better than people and process. So cloud software allows us to formalize responsibility and relationship between teams through APIs, permissions, and control. So once again, if you've used Amazon, so if you use Amazon AWS, you probably know this. This is nothing new to you because the only way you can interact with Amazon is through APIs. You don't ring up Amazon and say, hey, can you open up a network port for me? You just hit the API, go through the web UI and do it. So that idea is great. So how can we bring that in and apply it to all these kind of processes and people you already have within your company? So as private cloud infrastructure becomes more sophisticated, we can do automated deployments and we can automate more of that stuff to cover more scope. So private cloud can be a catalyst to allow traditional environments to begin to adopt DevOps easier. And that's simply because infrastructure as a service, private cloud, or even platform as a service helps break down those barriers. Because a classic example would be the storage team. So with certain like infrastructure as a solution services, OpenStack and OpenNebula, it's software-based networking. There's no real, networking. So how it actually works in a real implementation is there's an API people can hit, and it actually uses plugin type system to actually do the work on the back end on real hardware. So to give a real world example, there's an OpenStack project called Neutron. So it is networking as a service. It has plugins for all your different switches, for F5 load balancers and all that stuff. In the end, all it is just a Python daemon that just has some APIs that you hit, and then it just goes and actually reconfigures switches and load balancers to offer that stuff as a service. But it's really interesting and it's powerful because once again, typically networking, I'd say networking could be any group, or any group is often siloed off and they know what they need to do and they need that permission, they think they need that red tape. But if they start to think about what is it that I do, how can I just offer that to people, and then use policies as security and control to control that, I think it allows things to move quicker. So ops stuff. So the other way that infrastructure as a service or private cloud or even platform as a service can help those traditional silos in just between dev and ops kind of break down is that typically, once again, this isn't indicative of every company, ops staff know a lot about the platform and the lower layers, the hardware, the software, but they understand little about the application side. And likewise, developers understand a lot about the application side, but don't know much about the hardware and the operating system side. So if you take infrastructure as a service or a private cloud solution, it actually gives, once again, people a focus point for how they can delineate their responsibility. You can get ops to learn how to manage the hardware, the operating system, and the platform, whether it be something like OpenStack or OpenNebula or something. So you can draw the line of responsibility there, and they can learn and do that well. They keep the platform up and running. And then you can have operations building stuff, development building stuff on top of that. They can start, the APIs will be exposed, the interfaces will be there, the platform will be stable and supported by ops, and they can build instances and everything on top of that, and software-based networking and all the stuff they need to actually do that. That can be a start, and then what happens is dev can focus on deployment. Sorry, that's a point I already covered. So slowly ops can then work their way up the stack. They can start to then handle maybe taking on the management of the operating system and the instances on top of that, and then keep working their way up. And likewise, the opposite. So dev can start to work their involvement down as well. So the real thing is, and I think I've mentioned a few times, is it just gives everyone one environment to kind of focus on, or a catalyst for everyone to look and see how things work in a very clear point. So I'm just going to talk briefly now about building a private cloud based off OpenStack. So, I talked a little bit about the advantages of private cloud and infrastructure as a service versus platform as a service. So I'm just going to give, this whole topic could actually be a whole tech talk on itself. It's quite deep and involved. But I'll just kind of give you a brief overview. If you wanted to run out right now and do it, just a couple of points about that. So for those of you who are, you already have your own, configuration management, your own provisioning, your own deployment setups and everything for getting hardware up and running and managing systems. There are modules or cookbooks available out there for most configuration management systems for setting up OpenStack, be it Puppet, Chef, Ansible, whatever you use. Typically, there's probably some kind of module or cookbook or whatever your configuration system uses. There are a number of all-in-one solutions you may be interested in checking out specifically, which are just kind of a piece of software dedicated to taking a bunch of hardware and running OpenStack, and even some of the other tools like OpenShift and so forth on top of that. So they are PackStack project, which is one of the OpenStack upstream projects. There is Mirantis Fuel. So Mirantis is just a company dedicated to OpenStack deployment solutions. So they have a product called Fuel. RHOS, Red Hat OpenStack, we have a solution based off the Foreman project, which does bare metal provisioning, and then Astapor, which is some custom Puppet work to actually deploy once the operating system's up, to actually configure it for OpenStack. And then there's a very interesting initiative that was started by, I believe it was HP, called the Triple O initiative, which was OpenStack on OpenStack. So actually using a mini OpenStack installation on a live CD that you would put in your laptop to use OpenStack to deploy OpenStack on real hardware. So it's a very interesting idea. I've seen it work, as in I've seen a demo of it work. I've seen it not work many, many times. But once again, it's an interesting idea. And I think this comes back to the point of what I talk about innovation, private cloud, public cloud, and all the areas of innovation is it's about getting people excited and trying stuff like this, and if it succeeds, fantastic. And if it doesn't, well, at least they're wasting their time and not mine. So that kind of briefly, as I said, very quickly talks about some of the things you might want to write down and have a look at if you want to just go out and deploy OpenStack right now. So now I'll talk a little bit about then, you've got it up and running, it's all working, building on top of OpenStack. So once again, this is just a very short overview about some points and some things. I can go into these in more depth, but it can take a long time. So you want to look for deployment and configuration management tools that are cloud aware, and that's not just a kind of marketing buzz term here. What I mean by cloud aware is that they have a model where they understand that it's not just a system in isolation, which most configuration management and deployment engines do, And they also understand that they need to do tasks that might talk to APIs or services to actually provision machines before configuring the machines themselves. So an example, and to be honest, there's no configuration management tool or deployment tool or automation tool that can't do this. It's more depending on how difficult it is or what their support for that kind of is. So traditional, I'll give an example like Puppet, is, in a traditional sense, Puppet is a piece of software that runs on a server, dials home to a Puppet master and says, what do I need to do? And then it gets back some configuration change that needs to do and apply to a server. Compare that to some of the examples which I say are good examples at the moment, which include Ansible and SaltStack, which is up and coming. They adopted a different approach. They adopt a master talking out to everyone. So even that slight shift allows them to do stuff like the master can then go, well, I need to provision 6 servers on OpenStack or Amazon or anything else. I need to go to the database as a service and create a database so that, to take all that in, and then I'll actually go and configure the nodes themselves. Something that the dial-in model of Puppet it's a little bit more difficult to implement without kind of running Puppet first on a Puppet master and then kind of doing the orchestration. It becomes a little bit more difficult, but not impossible. So with private cloud, and once again, this should be nothing new for those who do public cloud, you want to try and make deployment from absolutely nothing to everything, which is incredibly difficult to do, depending on the complexity of the software. So in this example for OpenStack, you can leverage OpenStack projects that often can cover those manual or often overlooked steps and processes, including SSL cert generation, load balancer configuration, and VLAN separation and isolation. So what I mean by that is one of the architecture designs for OpenStack, and I believe a lot of the private cloud software out these days is to be modular, so people can build extra projects on top of it. So someone's written, there's an OpenStack project to do SSL cert generation as a service, and obviously that's something that if you run a public website you need to do, but you don't often think about it until your certificate expires and you have to run around and do all that. But you can have these kind of think about that, and you actually have it as part of your deployment recipe. I'll go to that service, I'll get the SSL cert, and I will apply it. So you include all that. So it's not just, your deployment recipe isn't just install the package and configure the software. It's turn on them, provision the machine, set up the networking for them, get the SSL cert. To try and cover as much of everything as it possibly can. So the goal is to have full automation of everything in one place that's across all aspects of the development and operation. And this once again speaks about using infrastructure as a service as a catalyst for kind of the DevOps idea. Because, and this is what I personally am working towards with an example I'll show you in a second, is once again that idea of if I can do everything, so I can set up the networks, every bit of the deployment automated in a configuration management or a deployment tool, even if it's just bash scripting or something, it gives me something I can go to every individual group and kind of everyone can look at that one kind of recipe and understand their role in it and understand and look for problems. So I can get the networking team to say, hey, look, I'm setting up 3 different networks, one for the databases, one for the web servers and everything. Is this look good? And they can actually see that. They can actually run that and see, no, this is wrong. And we need to change that. Even if you're not creating new network infrastructure, the network engineers can go in OpenStack and set up all your different VLANs and all that kind of stuff they like to do, and then expose that through an API so that your deployment recipe can consume, oh, this is the web server VLAN, or this is the test VLAN, and this is the production VLAN, and so forth. So it's possible to also deploy platform as a service on top of infrastructure as a service. You can deploy Staccato on top of OpenNebula, or OpenShift on top of OpenStack. So that can give you the flexibility of both, and that's a very interesting story, I think, that we're starting to see form as well. And there's some other projects that I'll mention about from the OpenStack side, automation engines like Heat and Celiometer. So Celiometer is a monitoring as a service. Everything is as a service. So monitoring as a service, which is an important point. So that folds into the systems themselves can report out to something greater than them. Oh, this is my CPU load, this is how many web hits I'm doing a second. And then Heat is a deployment scale-out automation tool. So those two work together. So you can say something like in Heat, you can say, when a system reports that the CPU load is too high, spin up 10 more web servers or something like that. Once again, there's Amazon equivalents. I think there's Rackspace has got equivalents to all this as well. So none of this stuff in the public space is new. So it's just, once again, this is the type of stuff you can use with infrastructure as a service privately as well. And once again, I can't remember, there's names for a couple of these that work with some of the other private cloud solutions as well. So before I kind of wrap up, I'll give you a it's not as deep a demo I would like, unfortunately. But unfortunately it was the kind of best I could do. So this is just, what I'm just showing you here is just a typical Red Hat OpenStack install. Besides the Red Hat logo in the top left, it's absolutely no different from any other OpenStack install. Any other vendor will sell you HP, Citrix, all of them now who all sell OpenStack installs, it's pretty much identical. And once again, if you're a user of Amazon, this should pretty much almost look identical. So as you can see, I'm starting with nothing. I'm starting with a couple of servers. Pretend they don't exist. They're just a couple of my test servers. And what I'm going to do, assuming it works, and I have a feeling it will be annoying and not work, is I'm going to use Jenkins here to actually do an automated deployment.
Just a little bit bigger.
Yeah, sorry, that's probably. So I just started this job here. So Cantas is just a basic web application that we use. It's open source and everything. So it involves a couple of different servers. It involves a Node.js server, an Nginx server, a Redis server, and a MongoDB server. So it's 4 servers it's going to deploy. And then it's going to get that whole service from nothing all the way up to running. So if we go down here. So in this example, I'm using Ansible. You'll see it mention the word drop there. Don't worry about that. That's just a code name for the OpenStack instance I'm using. It's just an internal instance. It's nothing exciting. So you can see here that it's just going through now and doing the tasks it needs to do for the cloud itself. So it's spinning up the instances. It's doing a bit of networking work. All of my instances are hidden in a private network that no one can see, except it exposes the web server out, the front door that people need to hit. That'll actually take probably a little bit, so I'll leave that crunch through. You can probably already see it start to do work here. So you can see, those new servers. These are the Node.js one, Mongo one, Nginx one, and Redis one already up and running. So I should be able to. So yeah, you can see they're just booting now. So that typically, ironically, one of the largest steps in any deployment process is actually waiting for the systems to boot. So that's what it's doing at the moment. So I'll continue on while that's running. I'll come back to that.
Can I ask, how did you find getting Jenkins and Ansible talking together?
Not too difficult, actually. So the way, one of the advantages I like about Ansible, once again compared to say Puppet or the other language configuration management tools, is it operates off SSH keys for security. So because it operates over SSH. And OpenStack, and indeed Amazon, the way you actually get onto a Linux instance in either of those solutions is via SSH keys. So it allows you to merge those two together quite well. I don't need to install an agent on the box. I don't need to set up any extra security. I can simply say, when you're creating these instances, I can give Jenkins an SSH key, and I can say, when you're creating these instances on OpenStack, inject that SSH key, and then Jenkins can, in the later steps of the playbook, when it actually needs to go on the host, it's already got everything it needs to authenticate and go into the hosts. So I'm just using the standard execute a command builder. It's really nothing exciting at all. And basically, I think you can see here, where's my mouse cursor gone? Yeah, that's literally the commands it's calling, just right there. So not that difficult at all. I'm not sure if that's, there's better ways you could do it. There might be plugins for Jenkins that could do better stuff, give you better reporting output or whatever. It just waits for the return code from Ansible, and if it's not 0, it says the build's failed. So it's not very intelligent, but it does work. Waiting. So, last thing I just wanted to talk about briefly is what I think the main points are for the future. So, the technology to do everything I'm kind of talking about is here and now. It is here and now, but it is rapidly changing, very, very rapidly, and it's growing quite a lot. The OpenStack project, once again, is probably the biggest example because it is the most popular project at the moment. They do releases every 6 months, and the rate of change in it is staggering. Like, they literally chop and change so much that the software becomes different, just completely different. And that's not necessarily a bad thing. It just means we're at that point where people are innovating and people are really kind of, excited and trying to do different things in that space so much that, a lot of things are sticking, some things aren't sticking. Likewise, if you go on GitHub and you just search for OpenStack, like projects related around it or new services people are trying to do, the list grows every day. Part of my job is to sift through that and find out what's good and what's bad. There's some good stuff, there's some bad stuff, but once again, it's getting people excited about those ideas. The lines between infrastructure as a service and platform as a service will start to blur. So even everything I've talked about there before with the layers of infrastructure as a service, platform as a service and everything, I actually think eventually they'll just disappear. And that's nothing to do with public-private cloud. That'll actually probably happen in the public space as well. The reason I say that is because platform as a service will become more mature and it'll start bleeding down. I think they'll give you more options at kind of the lower layers, things like operating systems and that. And likewise, because of that, I think infrastructure as a service will start to become more intelligent about the applications that are deployed on top of them. So, the classic example is things like Docker and CoreOS. So CoreOS, which is like an operating system designed for Docker, you can deploy that on top of Amazon or OpenStack, for example, and that kind of gets you towards platform as a service, even though you're still just using the infrastructure as a service provider. And then there's, the OpenStack example I'll give is a recently announced project Solon. I think it was only announced last month. I probably doubled the number of people who know about it just by mentioning it here. And that project is very interesting for me personally, and this is the reason I mention it, because it's leveraging a whole bunch of different stuff to try and make development onto OpenStack or any cloud provider a lot easier. So they're going to be using, it's very crazy, I'm still trying to wrap my head around it all, but they're going to be using things like Docker for container management, but then making your Docker cloud aware. So if your Docker application needs to have certain network requirements, it'll actually be able to integrate with different services and do the structure it needs. So it falls back into that idea of you as a developer, they're talking about IDE integration. We'll go into your IDE, be able to describe everything. I need my networks to look like this. I need this much storage from the storage array. I need 6 databases and all that. And then you'll just be able to press the magic button and it'll all work. Unlike platform as a service where it's very restricted, the idea is you can describe every single layer up and they're all supposed to work together and be in perfect harmony. It's an interesting idea. Who knows whether it'll take off.
Do you mean as the Docker nodes come up, essentially they're communicating out their requirements or something that's going to go, oh, okay, right, then my VLAN will now do this.
It's more that in your project's Docker file, you'll describe what you need network-wise.
Right.
So right now, you do your Docker container,
yes,
and it's natted.
Yes.
And that's it, bad luck.
Yeah.
But you'll have a Docker file or a set of them that describe the suite of stuff you need. And how they'll interact, not just with the volumes and the links that they have now, but also how the network interacts and what kind of resources you need. All of those lovely things that, well, we're not at one, so there's a long way to go.
Yeah, so things like that. So once again, it's about that idea of all these things of this is infrastructure, this is platform as a service, this is software. They're just going to start to break down as things start to, hopefully, as long as these technologies don't suck, start to come together, that you'll be able to just have these kind of, your IDE will be a portal to everything you need, and that's it. You can do everything you need. So the last idea I'll mention is, as private cloud technologies advance, the idea of hybrid cloud, so public and private, and using both, should become commonplace. So, obviously I'm a I'm a big advocate of private cloud, but I still feel public cloud obviously has a place. If you go out in the community, there's a lot of public cloud evangelists who will say private cloud has no space. They say the only reason private cloud exists is because people are scared of security and people don't like to change. But once we figure out all those problems, there won't be a reason for private cloud. But public cloud is it. It's superior. Private cloud is just a fad until everyone adopts public cloud. I personally don't believe that opinion. I think there's place for both, and I hopefully will see most people adopt actually a hybrid model of both. So that's it. Questions? Before I jump to questions, I'll just see if my thing's actually finished, or if it's exploded. No, still installing.
I think Docker, of course, this will be almost instant.
Yeah. Yes. So once again, I'm building like the operating system and configuring that. It is.
Yeah.
Exactly right. So, that kind of says speed and everything's installing in Unix. To be fair, also, the one I'm building it on, it's not the fastest piece of hardware in the world. It's one of my old workhorses, which I kind of abuse a lot, so it could be a little bit faster as well.
And I complain about my Docker instance taking a second.
Yeah,
It's like,
yeah. So there we go. It's all finished. But at least, once again, the model here is it's spun up my instances. I wanted to do a more complex networking example. Unfortunately, there's a couple of bugs in Ansible at the moment with related to some of the OpenStack integration that I couldn't. So the last thing here is you can see here I've actually, so the 192 is a non-routable, that's just a private network only for OpenStack. But I've attached a public IP to this instance here, so if all goes well, I should be able to do this. Go away. And you can see my application's up and running. Demonstrate it works, or it might not work. Go away. Go. And so there, you can see the applications running, clicking press buttons, stuff happens. So that's pretty much, so you can see I've got an actual running application, and that was built from nothing. So the process, what we're doing now is we're actually using that kind of stuff so that whenever people tag a milestone and anything within Jenkins, that we actually build a whole deployment for nothing so people can test the releases. And then obviously there's talk of even rapid deployment faster than that. So that's just a classic example, a bit of a small one, of doing everything, trying to do and automate everything in the one way, in the one playbook or in the one kind of control. So does anyone have any questions?
So how much of that demonstration is OpenStack and how much is on top of OpenStack?
Well, pretty much most of that is on top of OpenStack.
Yep.
You could do what I've done pretty much on Amazon
Yep.
with minimal change.
Yep.
You probably just need to change the OpenStack module in Ansible, probably just cut and paste with the Amazon one, and it'll probably do the same thing.
Was it building OpenStack from scratch as well? Was it?
No, so what that demo did is basically, I can probably show the recipe if I can. So it invoked, see if this works. Does Control Plus work? Might be a bit hard for people to see, but basically there's kind of, this actually does the outer cloud work, so it just uses the Nova Compute module from Ansible to actually say, go to this OpenStack instance, create some instances that look like this, and then I do some floating IP assignment based off if I tell that particular server needs a floating IP or a public IP, and then I just wait for them to do. And then the rest of the heavy lifting is done by just various different roles of it. So we've got different roles that you can see. There's Nginx, MongoDB, all those kind of things. So that's really just I've already got something, OpenStack's all up and running.
Yep.
I'm just deploying something on top of it.
Configuring and installing web servers.
Yeah. And once again,
databases.
that's not specific to OpenStack. You could do that on any private or public cloud with minimal change.
So the actual process of building your OpenStack, building your IaaS, your infrastructure as a service, would you drive that from Jenkins as well? Or is it...
Yep, so that can be done. So that's a very interesting space, and that's what I probably touched on, and maybe touched on a little bit too quickly to start with. There was a couple of solutions I mentioned back that are kind of specifically focused around building OpenStack itself. These are designed to be automated, so take Mirandus Fuel, for example. They're just a nice web UI. So how they look at it, let me start again. If you think of it from the hardware, starting from the hardware, hardware up, how hardware vendors are positioning it in partnership with these types of people is you'll go to HP or whatever and you say, I want to build an OpenStack cloud or any other private software cloud, and they'll actually won't sit there and haggle specs with you. They actually have pre-configured racks already set up in the configurations needed. And they'll just actually deliver the whole rack, gets off a pallet on a forklift, you plug some network cords into the top into your network, you plug the power in, and away you go. Software solutions like this come along then, so you've got a rack of hardware that's running nothing, so you might use any one of these, or you can write your own, and you can use Jenkins and all that kind of stuff to actually say, I've got 16 servers over here, please turn them on and run OpenStack on, and then they'll figure out how to do that. And that's everything from PXE booting and then all the way up to operating system installation, installing the software, and actually configuring the OpenStack software. But we actually have a big initiative within Red Hat at the moment to do continuous integration of OpenStack, but that's because we develop OpenStack. So we want to know when we break our product.
Sure.
Actually redeploying OpenStack for end users is probably not going to happen something too often. You may reconfigure a compute node if it acts up or anything. It doesn't mean it can't be done continuously, and it's probably something that it's the same way for those of you who obviously use virtualization and everything, like the whole hypervisor concept, the thin hypervisor and everything. The eventual plan is to move OpenStack to that kind of model as well. So you will be able to kind of do that rapid change to the environment and everything. And even now, things like Fuel and I think Astapor and stuff allow you to dynamically change the environment as well. So if you have an OpenStack compute node, but then you're like, oh crap, I want to throw a bunch of disks in that and make it a storage node as well, you can do all that kind of stuff quickly. And that can be driven from any kind of engine. And there's no leader in that market space. There's a project I actually missed out on called OpenStack M, or OpenStack Management, which Red Hat is heavily involved in, which is trying to make a proper solution for that, which is officially the official upstream OpenStack solution. But in terms of deploying OpenStack at the moment, it's kind of the Wild West. There's a lot of ways of doing that.
Yep. Sure. I guess you wouldn't create a Jenkins build for something that you're only going to do once. You only do your OpenStack on top of your bare metal once.
That's a good question, right? Like, so OpenStack is it quarterly or half yearly?
Half yearly.
Right. So, we built 4 racks 6 months ago. What do I do now?
Yeah, and these solutions, a lot of them are definitely looking at that space as well. And the idea is that all the components are supposed to be HA. So we're now justifying it. So there was one holdout in terms of the OpenStack components that wasn't HA compatible. So the next release, or the release that just happened, Havana, I think finally made that HA. So the idea is you would actually say, I want to upgrade, you press a button, you might take it down node at a time, or these solutions, they all want to be smart enough that you press one magic button and they'll actually cycle down and cycle up the nodes, and they'll migrate instances off compute nodes. They're very ambitious. Once again, when I see the demos of these things and they work, it's really awesome, but there's a lot of rough edges, so they've got a long way to go. But, it's not that you can't get it up and running. At the end of the day, you've got to remember Rackspace is running OpenStack at a huge scale, so it can work.
I guess that goes all the way up to your applications as well, developing them with the idea that the host that it's on could be restarted at any point in time, being resilient to that, and thinking about the whole stack all the way down, being upgradable.
Well, that's no different, right? Like, so like essentially the difference between public cloud and private cloud, you know, if you're just seeing it as moving applications into a virtual environment, it's not going to work. You know, like, so it's the same problem.
Yeah. Sorry, that probably went a bit longer than I expected to.
Any other questions? Well, join me in thanking Graeme for his time tonight.